welcome back to Pre-Algebra. We're going to continue today with slope-intercept forms. So yesterday we talked about slope, finding that, remembering that M is the letter that stands for slope, that when you find slope you're looking for rise over run. Another way to think of it is the change in y over the change in x. And lastly, y2 minus y1 over x2 minus x1. Interestingly enough, Quinn was doing some homework yesterday and working on his Algebra 1, and he needed to review some slope concepts. So I'm telling you that so you know that this is a concept that you're going to see many, many times in your math future. And if you have questions or it's a struggle, please come see me, come talk to me on Google Meet. Get solid at it now. Granted, I've given you some odd problems. That's not so you get to skip your work. That is not the intention of that. It is so that you can do your work, check it, and have immediate feedback. Yes, I'm on track, or no, I'm not on track. So make sure you're doing that like it's supposed to be done, and this is your chance when you are in 7th grade to master this concept and get really good at it, because you will have it again in the future. Today I'm going to cover 11.7 and 11.8 like I've done before, and like I tell you on RenWeb. Once I get through 11.7, you're welcome to pause it, do the work for 11.7, tomorrow watch the 11.8 video, finish this one, and do the 11.8 work, or watch it all today, do a little bit of the work today, do a little bit tomorrow. I guess that's the beauty of school at home, is that you can choose to do it how you want to do it, which is great. However works for you and you can manage is fine. Make sure you are watching the videos. You do realize I can see the views. I'm just telling you, I can see the views. So if you have questions for me, I'm going to assume you've watched the material that I've presented, looked at the examples. I'm covering most of the guided practice problems, so you have those to work through as well to get familiar with the concept that we're studying. Again, it'll cover 2 days. So I'll tell you when I finish 11.7, and then I'll do 11.8. But they go a lot together, so I'm just going to go ahead and shoot it out in one video today. 11.7, we're on page 622. And right off the bat, I'm going to keep it interesting and change colors for you. Slope-intercept form. As I mentioned yesterday, teaching you slope and discussing graphing these equations, which is what 11.8's lesson is. Remember, now you know that you can make a table and graph when you're given an equation. You know that you can plug 0 in for x and 0 in for y and find the intercepts and graph that equation. Slope-intercept form is yet one more way you can learn to graph. And it's very important. You're going to want to memorize this. Slope-intercept form is y equals mx plus b. What in the world? Okay, well, think of it this way. X and y you're familiar with. Okay, so those are coordinates, and sometimes you'll want to know that because you'll put them in there to see if they work for that equation. Hopefully you went, oh, m. That is the slope. Again, I write on this board, I'm hoping, trusting, this is your notes. These are your notes. There's my English. You should be writing this down as well. We're on lesson 11.7, page 622 for review for you. But these things would be good for you to write down in your notes. Slope is m. That is before x. Something to remember here. Slope is always a number, okay? Slope is never a variable. So when you have a problem that says, what is the slope of this line? Your answer would not be the slope is 2x. X is not a slope. Slope is the amount that a line goes up over the amount that a line goes over, okay? Rise over run. That is a number, never a letter. So that's important to know about m. Well, what's b? B is the y-intercept. In other words, where it crosses the y-axis. And it'll be a number, plus 7, minus 2. That is where it hits the y-axis. And since you've done intercepts, hopefully that's a little familiar to you. So, this is slope-intercept form. Y equals mx plus b. Y equals mx plus b. Memorize it. Learn what those letters mean. And I'm going to show you what that means when we talk graphing and do other things. Okay, so I'm going to jump right into the guided practice. Well, I'm going to leave this up there. Not because I'll forget it, but just for your reference, okay? We'll go ahead and I'm going to make a little graph over here because I think it's going to save me some time here. Give you a little shorter video. And now, these first ones these are great. I'm going to look at the guided practice, page 622. And I'm going to not write them all down, but they're asking you for two things: slope, y-intercept. Slope, y-intercept. Now, the great thing is they've got those equations for 1 and 2 in slope-intercept form already. So guided practice number 1, y equals 6x plus 1. Good, you can still see that. I'm going to go ahead and write these equations in here. And then lastly, negative 2x plus 3y equals 6. Hopefully that all shows up. Great. This is already in slope-intercept form. Y equals mx, a number in front of my x, plus b. What's my m here? 6. My slope for that line is 6. Where does this line cross the y-axis? At 1. Easy enough, right? Whatever number is in front of x, that's your slope. Whatever number follows x is your y-intercept. As you will see, that can be negative. If it said 6x minus 7, your y-intercept would be negative 7. Okay? Y equals 1/4 x. Is that slope-intercept form? It absolutely is. What you should notice is, what's the number after x? Well, 0, there's nothing there. That doesn't mean that there's not a y-intercept, and be careful of saying none or there isn't one. There is one. It hits the y-axis at 0. Okay? My y-intercept is 0. What is my slope there? My slope is 1/4. Little reminder, always keep those in fractions. Don't put those in decimals. Your slope is not 0.25. You don't want it that way. What does this mean if I'm graphing? Remember, rise over run. If I'm looking at what this slope means, oh, my slope is up 1/4. Just a little review. Now what you need to notice about this last equation, negative 2x plus 3y is 6. That's not in slope-intercept form. That's actually in what we call standard form. But I need the y by itself. So I'm going to rearrange this equation. So then it has 3y equals, and I'm going to put the x first because that's slope-intercept form, mx. Okay? So I have 2x plus 6. I still don't have y by itself, meaning the coefficient in front of y needs to be 1. So I'm going to divide out this 3. Every term has to be divided by 3. So my final equation there is y equals, you could write it 2/3 x or 2x over 3, either way, plus, simplify this, 6 divided by 3 is 2. I'm going to scoot this back just to make sure. Let me try and tilt that. There we go. That's terrible. Just so you can see that down there, okay? This moment, I just won't write that low next time. But y equals 2/3 x plus 2 is the equation there. So what is my slope there? 2/3 up 2 over 3. What is my y-intercept? It is 2. Okay? It's going to drive us all crazy, so let's straighten this out a little bit. go. Get us back. Try and have that lighting not be so harsh. There we go. Okay, so that is the first guided practice. Pretty straightforward. When they give you an equation, make sure you have it in slope-intercept form. If it isn't, you rearrange it. And again, put the x before the y-intercept. All right, so let's take a look at the next part. On page 623, numbers 4 through 6, guided practice. Down below, this is where the graphing comes in. Super fun. All right, now, graphing, numbers 4, 5, and 6, make sure you can see those. Y equals 2x plus 5. Y equals 7x. Negative x plus y equals 6. Okay, great. Now we have our coordinate plane over here. I'm doing these all by ones. So I'm just going to mark where my 2 is. While we're talking about that, it is important when you make a grid for me on a test or a quiz that you have some numbers on that grid. I need to know, are your lines going by 1? Are they going by 2? It's important that you indicate number values. It's also important, and I'll say this, some of you have just plotted points when you show me this. A graph is a line, okay? These are linear equations. That's what we call them, meaning they graph a line. So you need to connect those points. Just drawing points is not sufficient. So the first one, y equals 2x plus 5. First step on these always, you make sure it's in slope-intercept form. It is. Here's my key information first, is that it crosses the y-axis at 5. My y-intercept is 5. So here's my y-axis, 1, 2, 3, 4, 5. I put a dot there, okay? At 5, that's my y-intercept. What does the 2 mean? That's my slope. And if you are thinking, you recognize, oh, 2 is also 2 over 1 if I want that in rise over run form. Meaning up 2 over 1. Common mistake, kids go to the 0 to the origin and start graphing. Go to where you cross the y-axis. Okay, you're looking at the y-intercept there. Okay, so my dot's at 5. 2 means up 2 over 1. Up 2 over 1. There's my next dot, my next point. Well, you connect those lines hopefully better than I did. You should use a straight edge. And that is my graph of y equals 2x plus 5. I want to point out a couple things that are going to be important for the lesson tomorrow also. Like we said, going from left to right, my line is positive, you'll notice. It's going up. My number in front of x, my slope, is positive. If my line's going up, this should be positive. When this number is negative in front of x, your line will be going down, going from left to right. So pay attention to that. Y equals 7x. Again, you can recognize, and you don't need to write it, but it's going to cross the y-axis at 0. What does the 7 mean? Think of it like this. It means up 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. Wow. How very cool. I've got a line there that's going to have a little sharper slope to it. Okay, 7 over 1. And there it is. Okay. Lastly, my last equation is not in slope-intercept form, so I need to add my x here, add it over here. I get y equals x plus 6. All right, here's my point. It intercepts the y-axis at 6. Here we are. What's in front of my x? Hopefully you recognize, There's a 1 there. It's 1x. Up 1 over 1, up 1 over 1. So up 1 over 1. Interestingly enough, these graphs all intersect at 1, 1, 7. At some point you'll pay attention to that, but you'll see when graphed, interesting, those all came to intersect at 1, 7. That's a solution that actually works if I plug 1 in for x in all these equations and solve it, it will equal 7. Look, 2 times 1, 2 plus 5 is 7. 1, 7. Plug 1 in for 7. 7 times 1 is 7 plus 0, 7. Plug 1 in here. The opposite of 1, negative 1 plus 7 equals 6. Yeah, it makes sense. That point there that they all intersected actually works in all those equations. These lines all had positive slope. They were all increasing from left to right. All right, there you go for 11.7. I'm going to go ahead and move on to 11.8 at this point, so you can pause it if you like, or just keep watching. And I'm looking at 11.8, and we are graphing linear inequalities. And this is why I combined them today, because once you have that graphing of slope-intercept, this makes great sense to go right along with it. And it goes from what I just explained. So we're looking at 11.8, page 629. And the first thing they're asking, so they're talking about linear equations. Again, we said these are points, these are equations that form a line. That's what we're studying this chapter. We're talking about how to graph them. And in this part right here, it's asking, are these coordinates that I'm listing solutions for this linear inequality? So for guided practice, on page 629, it gives us the equation there, 2x plus 3y is less than 5, okay? 2x plus 3y, this is the equation we're using, is less, you know what I'm going to go ahead and do? I'm going to erase this, just so we have a little more room to look at our equation up here, okay? So the equation for this set, 2x plus 3y is less than 5, okay? The point of inequalities, meaning we are not using the equal to for equations. We're talking about greater than or less than inequalities, right? We have solved these before on number lines, maybe not quite on this coordinate plane, but you're going to get the concept, I have a feeling, very quickly. So what they're asking is, what I just showed you in the last section, does this solution, is this point a solution? Will this coordinate fall on that line? So what do? You plug it in. 2 times 0 plus 3 times 0, right? My x went here, my y went here. Is that less than 5? 0 plus 0. That is. Yes, 0, 0 will be in this area. Will it be exactly on that line? That we'll look at. But what they're asking is, if I plug that in, is that true? Is that less than 5? Yes, it is. So let's look at negative 4 and 2. In this case, I'm going to leave it in standard form. That's what we call it. AX plus BY is less than C. That's that form. But in this case, this is the easiest way to put these points in here. So, plug them in. 2 times negative 4 plus 3 times 2, is that less than 5? Negative 8 plus 6, that's negative 2. Is it less than 5? Yes. That coordinate, that point, would also fall in this region that I would graph. 5, negative 1. 2 times 5 is 10. And then we have plus 3 times negative 1 minus 3. Is that less than 5? 10 minus 3, 7. That's not less than 5. So no, that point would not fall, would not be a solution of this inequality. Okay? 1, 1. 2 times 1 plus 3 times 1. Is that less than 5? Interestingly enough, here we have 5 and 5. Is this true? It is not true because 5 is not less than 5. If I had less than or equal to, then this would be a solution of that linear inequality. But it does not have the equal to sign, so I would have to say no. That is not a solution of this linear inequality. When we graph, okay, when we graph these lines, if we have an inequality that just has a less than or a greater sign, I'm going to show you there's a difference. Again, great idea if you're writing these problems down, these information and examples down. So, if I have less than and equal to, greater than equal to, or less than and equal to, then I graph a solid line. If I just have less than or greater than or less than, then when I graph that line, it will be a dotted line. You would not include that line because it is not including points that actually equal it. It is only talking about solutions that are less than. So it would not include the solutions on the line. Oh, Ms. Winfrey, that's so confusing. Tell me what you mean by that. Okay. Let's look at guided practice, page 630. Okay. We're going to change over to red here. Page 630. I'm going to erase this. There are steps to when you have to graph an inequality. And I'm going to walk through those steps with you right now. So number 5, y is less than x plus 1. All right? So the first thing we do is consider solving that. All right, well, what if we had an equal sign there? All right, so we might want to say, you might put in there y. What if y was equal to? But I want you to notice there that on this it's less than, so we will not have a solid line when we graph it. How can I graph this? Now, you know multiple ways. Some of you might say, oh, I still love making that table of values, choosing all my points and making my t-chart, and x is this and y is this, and I'm going to choose -2 and -1. And I love that table. Some of you might say, oh no, I like to plug 0 in and figure out what the y-intercept and 0 for y and do the x-intercept. That's all great. However, this one I want you to use slope-intercept form. I want you to learn all 3 methods. You will have the chance to choose what's best, what works for you, but in this case today we're going to use the slope-intercept, and since it is in slope-intercept form, let's look at that. Here it is, crosses the y-axis. I forgot I erased all my numbers here. All right, crosses the y-axis. Just to kind of give me a gauge, I'm going to put 3 on mine just to see. Crosses the y-axis at 1. Here's my point. 1. What's my slope? What's my number in front of x? Hopefully you're like, oh, Ms. Winfrey, that's 1. I'm up 1 over 1. So here I go back to where I hit the y-intercept, up 1 over 1. And you could keep going. You could do lots of points, up 1 over 1. Up 1 over 1. You should recognize that that keeps going. So when you draw your lines, you should put arrows and not make it a short little segment. They should be lines, not short segments. Now, what I said is y is less than. So, I am going to do this really great strategy of just going back and making this a dotted line. Okay? That's my dashed line because I'm not including what works for x plus 1. Now, how do I know what places I'm talking about? What I'm going to suggest is that you pick the origin, 0, 0. And if I put x in for 0, and, 0 in for x and 0 in for y, is that true? So when I put 0, 0 in, 0 is less than 1. Is that true? Yes, that is true. So this point fits this inequality. I'm talking about this area down here because that includes the origin. All of these coordinates, if I tried to plug them into this inequality, would not make that true. They would not be less than. But any point down here does make that true. So you've moved from just graphing one line of an equation, to graphing an inequality. You're covering a whole portion. Let's go with a half plane. They talk about that on a graph, okay? So that's number 5. I'm going to see if I don't make too much of a mess. I can do another one. And we'll do this one in blue. Now, sometimes this gets a little messy, but I'm trying to save time here. 3x plus y is greater than or equal to 3. 3x plus y greater than equal to 3. Yep, I wrote that right. Okay, so first thing you need to recognize, that's not slope-intercept form, and I want it to be. So I'm going to move my 3x. Y is greater than or equal to negative 3x plus 3. And just by looking at that equation, I'm going to change my mind about trying to overlap a graph here, which would be a big disaster. So, you should be thinking, maybe you're already solving this on your paper, which would be awesome. You should look at that equation or inequality and recognize a few things. You should recognize that there's a negative slope in front of that x. So my line should be going down, okay? Wherever it is, my line should be going down. 1, 2, 3, 4. All right. I notice my y-intercept is 3, so I'm putting my dot at 3. Now, negative 3 over 1. That means I go down 3 over 1. So I go to my y-intercept at 3, down 3, 1, 2, 3, over 1. Okay, I can go down 3 and over 1 from there too, and over 1. Okay, and again, you're going to graph this line. Now, I'm paying attention this time. I do have the equal to sign, so this graph is a solid line. Okay, solid line there. Now, which side am I talking about? Which side is going to be greater than? Well, I'm going to put 0 in for x and for y. Remember, I like to pick my origin. That's the easiest way to put it. So 3 times 0 plus 0 is greater than or equal to 3. 3 times 0 is 0 plus 0. Is 0 greater than or equal to 3? It's not. So I will not shade this side. I will shade the other side because the origin did not fit this inequality. So I don't shade where the origin is because it is not a solution for this inequality. All right, I hope you're getting the hang of this. I'm going to do one more for you here. We'll do number 8 on this guided practice. And then I will give you a chance to practice today. So, I'm going to go with 7 here. obviously when you are graphing, you must graph these on graph paper. You do not want to just freehand these. You need to be in the habit of getting exact answers. Oh, I'm going to do 7 and 8. I'm trying to do these in a hurry. So 7, x minus 2y is greater than or equal to negative 1. Negative 2y. This is a great one to do because I have to move my x. So I get negative 2y is greater than or equal to, and I just subtracted my x. Notice I need y by itself, and hopefully you remember when I divide by a negative, I flip my sign. This is massively important, as you can imagine, in this graphing for greater than or equal to when you're trying to determine if it works. So you flip that sign because when you divide or multiply by a negative number, you flip the inequality sign. All right, so that canceled out. I've got y. All of these by a negative 2 becomes x over 2 plus 1/2. So my y-intercept is 1/2. What does this mean? 1/2, up 1 over 2. So I'm at 1/2, I go up 1 over 2. And there's my next point. If I wanted, I'd go up 1 over 2. Okay? This has the equal to sign, so I can go ahead and graph that straight line. Put my arrows at the end. It's hard to tell, but my point's at 1/2. So let's see what happens if I put 0 minus 2 times 0 greater than or equal to negative 1. 0 minus 0. So is 0 greater than or equal to negative 1? Yes, it is. So my inequality here, the solutions are all down here. They include the origin, the solutions for that inequality, excuse me. I'm going to look real quick at number 8. It says y is greater than or equal to negative 2. Do you remember what a y equals equation looks like? A y equals inequality looks like that too. Meaning, if it's a y and no x over here, okay, it does mean that, hopefully you recognize, when you just have y and the number, what kind of line was that? A horizontal line at negative 2, okay? It does include, so I have a solid line there. Y is greater than or equal to negative 2. That's right here. All right? It is a solid line that equals it. Now, is there a slope here? There is no slope, right? So we would say there's 0 slope. Because we could write 0x if we wanted. 0x minus 2. And that would still be true. So remember, your horizontal lines have 0 slope. This is not it's not undefined, it's 0. All right, and the other thing is, are we talking about the area above or below? So if I put 0 is greater than or equal to negative 2. That's where my origin is, 0, 0. Does that work? Is 0 greater than negative 2? Yes. So I am talking about all this area above that line. And my lovely mess of a graph, but we'll just call that my modern art. That's what that is. Again, let me know if you have questions. Hope it goes well for you. Good luck.